worksheet 3, it should have been on your desk when you came in. This lesson is really short because we talked about most of this last week, so you will have time to get to work on the book work in a minute, and I can put it up on the screen so that you can work on that as well in class. There is not a homework check due this week because I'm giving you time to work on a worksheet on Wednesday, and I don't know if everybody will finish, so it's not due this week. But if you don't want homework over break, just keep up Monday, Tuesday, Wednesday, and you'll be good. Okay? Like I said, you'll have time to work in a few minutes here. This is more stuff on vectors. We already did a fair amount of this because we talked so much about component form when we did 8.1. All right. The little bit difference in this section is, as it says, they did those by drawing, and you often need to be more accurate than they were in 8.1. They're also going to use this, oh, I don't know what that is. That's supposed to be a P. They're also going to use this notation to talk about a vector that goes from O to P. And they're going to talk about the fact that when you know it has components of over 3 and up 2, it could actually be anywhere. So, given a vector that goes from this point A to this point B, so if I quickly sketch -4, 2, and +3, -5, and I was talking about this vector that went from here to here, what are its components means what does the x do to go from A to B? How do you get from -4 to 3, guys? Okay, it went to the right, or added a +7. And for B, or I'm sorry, for the y coordinate, it went from 2 to -5, so it went down 7. All right, so if you want to do it mathematically or arithmetic by just subtracting, you would have to do the second point minus the first. So if it's going A to B, you have to do the B coordinates minus the A coordinates. All right, I just think about it logically. It will also ask the magnitude of that. Does this look familiar to everybody? We're just doing Pythagorean theorem to find the magnitude. Okay. So if I were doing from -7 to +6, I would be going up 8. From -7 to +1 also goes up 8, right? So then if I wanted to do the magnitude of that vector, this book only uses a single absolute value thing, but you would do 8 squared plus 8 squared and then square root that. All right, what do you have on your sheet? You have this example. So you can say to yourself, from 2 to -4 is down 6, or a -6. You can also subtract, but you have to do the second one minus the first one. And then for the y component, you would do 2 minus -3. I would just think to myself, from -3 up to +2 is 5. Everybody okay with where they got those components? Then how do you find the magnitude? That's not anything new. Be -6 squared plus 5 squared, square root. 36 plus 25, square root is 61. Does that sound right? Or some decimal? Everybody okay? What magnitude is? So let's try a couple of these. If the vector goes from A to B, what are its components? You can do 52 minus 12 and 33 minus 41. Or you can just say to yourself, I went from 12 to 52, so I went up 40. But I went from 41 to 33, which is down 8. Everybody okay?
Does it matter doesn't matter. It's x2 minus or x1 minus x2.
Yes. Because it's saying here in the directions, the reason that matters is because this says you're going A to B. If you do them in the other order, it would be the vector B to A. Okay? Yep. All right. Then it also said, and find the magnitude. So this would have a magnitude of 40 squared. I think that's 1664. Anybody get a decimal for me? Okay, so approximately 40.8 is the magnitude. All right, can you guys try 2 and 3 quick?
Yep.
Any questions on what we're doing there? Just remember to subtract in the right order, or to really think about whether it's going up or down as you go from A to B, or left or right. Everybody okay? This is kind of a review as well. We talked about, excuse me, sorry. You can add vectors, subtract vectors, and you can multiply by a scalar. Multiplying by a scalar is just taking the direction and keeping it the same, and multiplying by something like, if you multiplied it by 2, it would just make the magnitude twice as long. They spend a lot of time on this in your book and assign a bunch of questions. I didn't assign very many because this is very basic. You just add the x's and add the y's. So s plus t would be what? Positive 3, 5. Yep, you're just adding. Here's an example with a scalar. They did 3 times s and got this, and then they added t and came up with this vector. Again, they got a little crazy. The first one here is not bad. It's just f minus g. So 4, negative 2 minus, sorry, can't make the parentheses, 24, 21. Negative 20, negative 23. Anybody else getting that? Okay. What? Yes?
Yeah.
All right. This one says to take G, which is 24, 21, subtract 2F, which I'm going to write as 8, negative 4. So I multiplied by the scalar already before I wrote it down. Is that okay with everybody? And then it says plus 3h, and again I'm going to multiply by 3 before I write it down. Alright, so now what happens when I add those x's? 24 minus 8 plus negative 3. I'm getting 13 in my head. Is that right or not?
Yeah.
Okay. 21 minus negative 4, which would be plus 4, is 25. Plus negative 9 is 16, maybe? Yeah. Okay. All right. I didn't assign as many as they did in the book of these. They did some crazy business. Like this one says, add G plus 2H, then take 2 times that, and then subtract it from F. Okay. If we start in the parenthesis, 24, 21, plus 2h, which would be negative 2, negative 6. What do we get in there? 2215. Everybody okay? Then there's a 2 in front of that, so that would be 4430. And then we're supposed to be subtracting that from F. Anybody come up with anything? Yep, negative 40, negative 32 is what I had as well. We all right?
Yep.
I mean, I could give you 50 of those, and I'm sure you could do them. It's just tedious. It's not anything very exciting. All right. When you does anybody remember when we were learning the unit circle and I said back in geometry you learned this, x, and x square roots of 2. And then in this class we wanted to use a unit circle, so we wanted this hypotenuse here to be 1, so we divided everything by square root of 2. And so then we came up with, if this is 1, this was 1 over the square root of 2, or square root of 2 over 2, and square root of 2 over 2. Remember when we were doing that on the unit circle? A little bit. This idea that you want the length of the vector, or in our case the radius, to be 1, is what they're talking about here for a unit vector as well. So I messed up on the notes and tried to confuse you with 2 different ideas in the same problem. So just ignore this right here. We'll talk about that in a second. But they're talking about a vector that from the origin goes negative 4, negative 1. They want you to switch it to a unit vector. So if I were to graph this, it would go left 4 and down 1. So what is this hypotenuse? Can you find the magnitude of that vector? Square root of what?
Oh, I screwed that up.
17. Everybody okay? We're adding, right? Because this is the hypotenuse. So what would we have to divide all those by to make this vector length here be 1 instead of square root of 17? So we have to divide everything by square root of 17. Now, the hypotenuse is 1, and we have some crazy business out here. The x to the left is negative 4 over square root of 17, which we have to write negative 4 square roots of 17 over 17. Everybody okay? Rationalize. And what's the y component then? Yep, negative square root of 17 over 17. So these don't turn out very nice, but that's all you're doing is taking the components, the xy components, and dividing by the magnitude to make it a unit, 1 unit along the vector length. So this one actually is one of the few that will come out nice, right? If we go over 4 and down 3, what's the hypotenuse? Which is 5, okay. Then how do we write the unit vector? The unit vector means you have to take each of these components and divide by what? Yeah, the magnitude in this case, which is 5. So the unit vector would be over 4/5 and down 3/5. Are we okay?
Yeah.
There's, I think I put it here. You just take the vector v, whatever that vector was, which had an x component and a y component, right? And you multiply it by the magnitude, or divide 1 over the magnitude, or divide it by the magnitude. Everybody okay? All right. Oh, try this one. This one doesn't come out as nice. If we do the magnitude, We get like 725. Did I do that right? What goes into 725 that's a perfect square? It's 25 times 29, so we get 5 square roots of 29. Isn't that lovely? So then we have 10 over 5 square roots of 29, which will become what? If we do reduce that, we get 2 over the square root of 29, or 2 square roots of 29 over 29. Aren't these exciting? Such beautiful answers you get. And the y was 25 over 5 square roots of 29, which is 5 over the square root of 29, or 5 square roots of 29 over 29. You do need to give these as exact answers. I didn't assign like 20 of them. I think there's 3 of them or something to do, okay? Any questions about where we got any of those numbers? All right, there's another way to write this that they will use sometimes in some of your calculus courses if you get there. They will say anytime you move 1 unit in the positive, in the x direction, they call it a vector I. It's a 1 unit long vector in the x direction. And j is a 1 unit long vector in the y direction. So guys, all they're saying is that this vector can be written as 2i vectors plus 3j vectors. Or if you had -7, 4, you could write it as -7i vectors plus 4j vectors, okay? Super easy. They call it linear combinations of I and j. It did say on this slide, notice that I is not the imaginary number. And it's very clearly not, because it says when you use imaginary number, it's italicized. Would you really have noticed the difference? Not so much. All right. So on this question, it says if you want to find the linear combination of the vector that goes from m to p, again, m to p goes up 3, or right 3, I guess I should say, and up 2. So as a linear combination vector, that would be 3i plus 2j. So let's look at this one. How do you get from m to n? And you can write it out like we did earlier if you want. You get what? Left 7 and down 6, 11. I can, yep, I don't even know where that 6 came from. So what would that look like as a linear combination of I and j?
7i minus 1j.
Yes, if I could write, it would be minus 11j. All right, so try this one. 0 to 18 is 18. 6 to 4 is -2, right? All right, so nothing tricky about that. Everyone okay?
You should divide that by 2, or is that wrong?
You'd still have to leave the 2 somewhere. You could factor it out, I guess, as a scalar, but there's not really any point. All right, then this should look extremely familiar. Do you remember doing this?
Yeah.
Component form. Okay, we've already discussed all this. Component form. They do ask on the homework that if it is something off the unit circle, you do it as an exact question. I'm not going to get too worried about that on a test or quiz, but it could be a multiple choice question. Can you find the sine and cosine of 240 exactly, guys?
Yeah.
Remember this?
Yeah.
It's been a little while.
Error off the top of my head.
240 is -1/2, negative square root of 3 over 2 from our unit circle.
Yes.
So what would the components of this be if you have to do 18 cosine of 240? oops, I don't know what happened to the 0 there. 18 sine of 240. In exact form, you'd have 18 times negative 1/2 and 18 times negative square root of 3 over 2. Can you simplify those?
Negative 9.
Yeah, that was a negative. I don't know what happened to my negative.
Negative 9 square root of 3. Yeah.
All right, so if it's something you can use the unit circle for, do it, because it's good practice and a good review of the unit circle. Is 95 on your unit circle?
You wish.
So this one is really nicer for those of us who just like to type things in the calculator. You just type 5 cosine and 5 sine. Anybody have some decimals for me?
Negative 0.4. Negative 0.44.
4, 4 or 4, 5?
4, 3, 5. 4, 4.
Okay. And this one?
4, 5.
Thank you. Does that make sense, guys?
Yeah.
If you went 95 degrees, you just barely went past here, right? If you went out 5 units, the over would be very short, but the up would be close to 5, right? Because this was actually 5. All right. Nothing new here either. To find the directional angle, you do inverse tangent or second tangent of the y over the x. We talked about this last week, right? The thing you need to be focused on when we're talking about the coordinate plane, remember we had a lot of trouble finding the right angle they wanted last week? Like, did they want off of a bearing? Did they want off of north, south, east, west? What did they want? These are not directional bearing questions, but you have to be in the right quadrant. Look what happens. If you're doing this question right here, you do inverse tangent of negative 5 over 4. The calculator gives you negative 51. Is this 4, negative 5 in quadrant 4? Well, 4, negative 5 is in quadrant 4, right? This is a negative 51.3 degree angle, and I would honestly take that. Okay. What's another name for that same spot? You could do what? Add 360 and get 308.7. But let's talk about these two questions real quick, and then we'll do the 2 on the notes and we'll be done. Negative 6, 2 is the same as this vector, as we've discussed. What quadrant should that be in? Negative 6, positive 2 should be here. You know how to find the magnitude. Now we're asking for the angle. So we're going to do second tangent of 2 over negative 6, but it's not going to give us the right answer. When we learned inverse tangent functions, we learned that, and we colored our unit circle, remember that? The colored unit circle gives us answers only in 1 or 4, so it thinks we are negative 18.4. Did someone else get that? Did I type it right? Okay. How do we get this answer instead? Yep. The tangent has a period of pi, right? The same angles reoccur every pi, so we're in degrees, we're just adding 180. If we add 180 to that, well, I get 161.6 because this angle is 18.4, right? We want this one, which is 161.6. So you just have to be careful what quadrant you're in. 7b is in what quadrant? Yeah, negative 3, negative 8 would be in quadrant 3. What are we going to type to find an angle? Negative 8 over negative 3 is going to be a positive. Negative divided by negative is positive. Inverse tangent of 8/3 is 69.4, which is in quadrant 1, right? How do we move it around? to here. Yep, we just add 180 again. So 249.4 would be the angle they're looking for. All right, let's try the 2 on our worksheet and we'll be good. What quadrant is this in? -4, +2. So I type what? Okay, inverse tangent of -1/2 or 2 divided by -4. Now, it thinks we're down here at -26.6 degrees. What do we need to do? Add 180. Does that seem right? Would it put us over here in quadrant 2? Okay, so this is the angle that I need you to answer. 217, this is an easy one. Do we have to do anything? No, because it's already going to give us a quadrant 1 answer when we type in inverse tangent of 17 over 2. We get what? 83.3? Is that in the correct quadrant? Yes, so we're good to go. All right. The book assignment is a couple problems here and a couple there because I just assigned a couple of each, okay? So this is what you need to be working on. There are books in the closet as well